In this video, we're going to talk about solving two-step equations with multiplication and subtraction. Okay, so again, with two-step equations, the first step will be to isolate the term with the variable in it. The second step will be to isolate the variable itself. We're going to use both of those processes by using opposite function, same number. We're gonna, if it's added, we subtract. If it's subtracted, we add. If it's multiplied, we divide. If it's divided, we multiply. Okay. Remember, our goal is to have our final equation be x, or whatever variable you're using, equals some sort of number. Okay. So let's look at our first example. 2x minus 3 equals 11. This right here, the 2x, is my term that contains my variable in it. That's the protective force field in red that I've just put around it. So we have that protects it. So I got to get rid of everything else on that side of the equation that's not in the red circle. So that's a minus 3. So how do we undo minus 3? We add 3. Adding 3 is the opposite of subtracting. So we add 3 to both sides. 3's cancel out. I'm left with 2x equals 14. There's my protective force field around just the x, because in my second step, which is what I'm getting ready to do, the second step, I isolate the variable by itself. So what I need to do is figure out what's happening to the x. The x is being multiplied by 2. So with the x being multiplied by 2, to undo it, I divide by 2 on both sides. Therefore, those 2's will cancel. X equals 7. 14 divided by 2 gives me 7. So we move on to our next example. 4x minus 9 equals 27. This is the term that has the variable in it. So I have to get rid of the minus 9. How do I get rid of minus 9? We plus 9 or add 9, whichever way you want to look at it. Plus 9 to both sides. Those cancel. 4x equals 27 plus 9 is 36. There's my protective force field around the x. What is happening to the x? It's being multiplied by 4, so we have to undo that by dividing by 4 on both sides. X equals 9. Now, there are some of you that may be asking yourself, well, why is he getting rid of the 9 first, and why did he get rid of the 3 first and not get rid of the coefficient on the x? It's a good question. So let's look at our original problem. 2x minus 3 equals 11. If I got rid of the 2 first, remember the 2 is multiplying, so we have to divide. That means I would have to divide the whole thing over here by 2, and then divide that by 2. So that means it would get rid of, make that 1x minus 3 over 2 equals 11 over 2. That's where that would get us. And I don't know about you, but I'm not a real big fan of dealing with all of these fractions. Okay, so we're going to avoid that by isolating the term of the variable first, and then isolating the variable itself. I'm glad you asked the question. So now we look at our last example. Negative 3x minus 12 equals 36. Again, the protective force field around the x, the term with the variable in it. We have a minus 12. We undo that by going positive, plus 12. Plus 12 on both sides. Those cancel. The 12's cancel. Negative 3x equals 36 plus 12 is 48. There's my variable. I got to get rid of what's on the outside of that circle, which is the multiply by negative 3. So we're going to divide by negative 3 on both sides. Those cancel. X equals positive divided by negative is a negative. 48 divided by 3 is 16. Gives me my final answer. Now, how do I check and make sure my answers are correct? You plug them right back into my original equation, and we check them. So as we look at our original equation, our 2x minus 3 equals 11, I came up with my answer of 7. So we plug it in. 2 times 7 minus 3 equals 11. 2 times 7 gives me 14. Minus 3 equals 11. 14 minus 3, 11 equals 11. Therefore, we know that my solution was correct. And you can apply that to both of our other problems. All right. Isolate the term with the variable, isolate the variable itself. Those are our two-step equations. Thank you.